If your database search only returns results when you have exact wording match as the results in database, then this video is for you. Here we're going to be learning about how to implement vector search on our database so that we don't just get results which have exact word matchings, but also we are going to get results when we type out words that have similar meanings to the words that exist in our database. So my name is Kelsey Fonri and I'm a software engineer and also a founder at Axon Systems, which is a startup focused on automating business operations with AI. And here we're going to be implementing vector search. So before we do get into that, there are some keywords in vector search that we need to talk about. So before we go into that, there are two types of searches. We have a keyword search and a semantic search. Keyword search occurs when we are trying to fetch out for certain keywords within a text. For example, we could have a blog post that gives off some story about something, and then we could do a keyword search that picks out just the about. The next is the semantic search, which is a search that not only looks for certain words but also looks for things that match in meaning. For example, we could have the first one here where the user types cheap laptop for students and it returns result. But what if the user type affordable computers for college? This is quite similar to this in meaning, but the text has been written differently. So in this case, we'll need a semantic search here, a search that is based on meaning and not finding keywords in the data. So to go into that, semantic search is based on the practice of converting input words like this into what we call embedding, and that is done using embedding models. So an embedding simply is the vector text or the numerical representation of our data. For example, the user could type out something like cheap laptops for students, and during our implementation here, we could convert that into an embedding, which would be a numerical representation of that number. And when we do that, now we compare those numerical representation using vector similarity methods like Euclidean method, the cosine method, etc. So the architecture of, or basically the tools we'll be using, I will have Python, which will be a programming language, a Hugging Face model, which will be an embedding model. So I forgot to mention that in order for us to go from our human readable text into our embedding, we'll need to have an embedding model, which is a model that has been trained on a huge amount of data and can take an input text and represent it into its equivalent numerical form. So we have pgvector, which is an extension on the Postgres database that enables us to store our vectors in the database. So usually we used to have databases and the databases only take things like string, text, date times, etc. But in order for us to be able to store our vectors in the database and do operations on those vectors, we will need to install the pgvector extension, which is available only on Postgres database. So definitely we need a Postgres database and we need an embedding storage, which is still our database that we are going to be using. So let's go diving into it then. In order to begin, to set up our database, I created a compose.yaml file found in the project here that you can use. So within this file, I've described the necessary things for our database so that we can create it using Docker. So once you have set up the image, this image already contains the Postgres database. We add this and we state the user, the password, and the database name and the port which we want it to run. So we want it to be exposed with the 5432 port. So once you're done with this, you're going to run the inside cd docker postgres. You want docker compose up-detach, and it's going to run the Docker container. So I've already run this, so that's why it shows already running. But in your case, it's going to probably download the Docker images which of the Postgres database and pgvector with pgvector enabled. Yeah, so once this is running, we are going to set up our database. So I created this database called AppDB here. When you open it, it looks like this. So we're going to import that database. It just contains a single table called sentence, and then with two columns, the sentence and the embedding. So the sentence column is a bunch of text about 200 lines long, which I extracted from a book called Diary of a CEO, which is a book I love reading. So I want that we are going to use this such that we are going to be able to search text similar in meaning from that book without having to type the exact keyword from the book itself. So after setting up that database, which you are going to import it into your Postgres, you can just ask AI or whatever on how to import the SQL database. We will not cover that in here. So when you're done with that, we'll begin this. So I set up UV as my package manager here. So you can download UV, and then you run UV. You need to create it to initialize the project, and when you initialize the project, you can add your dependencies, which we had. If I check, we just need some few dependencies from here, which are numpy and the sentence transformer. I just added all of this because this is my machine learning playground where I try out new stuff. So the first thing we do is we're going to load the name of the model which we are going to be using to convert our text into vectors is called sentence transformer or mini lm version 6v2. So if you want to read more about this sentence transformer, there is a link sbird.net that describes how we can set it up and get it working. So this is how you install it with Conda. If you are using just PIP, you can use this. And the next thing is you can go through like the usage. I think you can just click usage here, and it shows you how we call it. This is like a basic array, and it's just a model.encode to produce the embeddings of this array. Yeah, so that's how it works. So once we load this embedding, we need our database connection string, which help us connect to our database. So our host is localhost, port is what we set up. So you're going to be repeating whatever you put in the Docker file. The database name is this, and that continues. Then I created a function that's going to take in a list, and is going to produce the corresponding embedding for that list. So for example, we could have something like sentence 1, sentence 2, just like that, and it's going to produce the list of embeddings 1, images 2, just like that. So that's how this works. And yeah, so it will return the result then. So we could try it out with a basic example here, where I can just say generate embeddings for the word hello, and you return that. And when we run this, return outside. We're going to just call this here and print it out, and it's going to take some time depending on how fast your computer is going to generate the embedding. So there's something to which I have done here which I would like you to take note of. So here I put MPS and MPS, which is just a max own processing unit to ease the for the model. So you can just change this to CPU here, depending on if you're using a normal Windows computer which doesn't have GPU support. But I'm just going to keep mine here like this. So doing this is kind of like a way of telling you that I want the embedding to be produced in using parallelization to get more speed. Okay. The next thing we wanted to do is I just went ahead and wrote the code since we don't have time to type up everything to reduce the length of the video. So our goal here is we are going to go through the database, and for each of these sentences here we are going to call the generate embedding, and we will get the embedding and store in this column here called the embedding column. So that's what this is supposed to do. Here we create our connection for the database, and then this is our query to fetch everything. Fetch all sentences query. Then once we have that, we are going to create a new cursor, which is like an instance that you can use to access your database. And we're going to do this batch. So I just did this batch operation so that we can process it 100 at a time to avoid using too much memory and to also get things done faster. If we are doing it one item at a time, it will lead to the n+1 problem, where we are going to be running queries for every single item. But we want to fetch everything, and we go in batch sizes of 100 to process and store those results in our database. So it means we are going to do the first 100 and then we go to the next 100 and we are done. So we're going to fetch based on that batch size of 100, and if it does not exist, we'll leave. We get here, we are getting the first item, which is like the ID of our item, which is what these numbers here, and the next is our sentence. So we're going to put all of the batch, the text in an array and the IDs in an array, and we'll call generate embeddings for the text. So it means for the first 100 text, we're going to generate an array of embeddings as seen on this line here. So here we're generating embeddings, and if has attribute embedding 0. So I'm checking if the first item has the ability to be converted into a list. So basically, sometimes when we call this embeddings function, the generate embedding function is going to when we call the generate embeddings function, it's going to return a numpy array. And I think it's even a point where I had a strategy that converts to numpy. So this is just me doing error checking, saying okay, if it's a number array, then there's definitely a toList function. So if so, then convert every item to be a list. So instead of us having something like this, we'll have a numpy array, and then we'll have the value and another numpy array and the value. We want that it should give us something where we have just normal Python list that we can iterate through like that here. So now we are going to update data list. We're going to zip the embedding and the batch IDs. So zipping is like combining them into a single tuple. For example, we could have an array called with A, B, C, D, E, and then we have another array with F, G, I, H. But so now if you want to zip these two arrays, we'll have something like an array with A and F, another one with I meant to say tuple with F and with B and G. So it's simply grouping the items based on their indexes like this. So that's what we're trying to do. We want to group them based on the embedding and the batch ID, so that we have, let's say this pin is inevitable and the ID 135, just like that. So we can now run this query to update the embedding with %s, which will be the first one, and on the ID %s, which will be the second one, and we pass it here to do a bulk update. So yeah, and then now when we are done with this, we're going to commit changes. If you don't commit your changes and you close from this loop, it's not going to save to your database. So this line is very important. So if I run this here, it's going to take some time, and it's going to generate all the embeddings in our database. You see the first batch has been completed of 100, and the second batch is 99 has also been completed. So if we go to our database and we check this out, we see our column of embeddings is filled out with all of the corresponding embedding for the data. So now where we are going to apply vector search, let's say our user says somebody has something where you talk about the 5 buckets of life. So I just wanted to try this out, but I'm just going to change this to let's say persistence, to bit of persistence. If the user wants to look for something about persistence in the book, how are we going to find things that are similar to that? So we're going to convert that query into an embedding by calling the generate embeddings function, and then we have the query embedding. We're going to select the first item, since there's just one single item that will pass to this array, one just that one single item here, because it releases an array of all the items. So we're going to create our connection, which is this. We have to call register vector from pgvector here, because we are about to do a vector operation in database. So we have to run this function here to prepare that. If you don't call this, is going to give an error, because we can perform this kind of vector operation without having that instantiated. So now we run our query, which will be select the sentence and the embedding from sentences ordered by embedding that match that are closest. Using this uses one of the types of comparing the similarities, and then you pass in the next number. So it's going to check which sentences is closest to this current embedding, which is the embedding of the word persistent. So if we run this now, it's going to carry that out, and we see that we are going to have things close to that. So we have absorb, what is useful, discard what is not, and what is uniquely your own. So this is kind of not really, we don't have that exact keyword match here of persistence, but it's trying to look for things that are closest to that since it wasn't able to find that keyword. Motivation is garbage, discipline is reliable, very close to the meaning of persistence. The greatest glory is in living lies not in never falling, but in rising every time we fall. Trust is gain. I'm just not going to continue reading all of that. So we have all of this set up now, basically for a model, and I'm going to add the link for this code base to the description, so you can run it and play around with it. So last thing I'm going to talk on is the applications of this. So real applications of semantic search would be in search engines. For example, Google doesn't have to have us type the exact keyword of something to give us that thing. For example, I could say $1 billion company making chips, and Google is going to give me Nvidia. Talk about Nvidia probably. So it basically didn't have to look for, the company didn't have to basically list that in whatever the pop. It just had to look for things that are similar to that meaning. And there's the recommendation engine. YouTube works, and Facebook and all of these platforms, they try to look for things similar in meaning to what you're currently doing. So not just text can be converted into embeddings, video, images, audio, and all sorts of data can be converted into images. Resume matching, companies use this to check out for people who match what they need. For example, they could look for resumes from a pile of resumes that are similar to people who are doing, maybe if they're looking for data scientists, they could look for people who resume match the meaning of the word data scientist, and they could easily filter out people who are talking about something which is not what they need. And the next is chat retrieval, and lastly RAG systems. So RAG systems are systems that are using embeddings to augment the capabilities of existing models. They can answer based on your data that you give them. For example, you could upload a PDF of your class notes to an LLM, and then the LLM answers your questions based on that class notes and not based on general training. So that is it for this. This is the first step in building AI-powered systems in public. In the next video, we'll optimize this with indexing and performance tuning. If you're serious about building modern backend systems, subscribe and follow along.